Good morning, student. So today's we will going to have a Python Panda programming, and Python Panda programming here we will going to have a conditional loop of iterations and implementation of the function and the Armstrong number. So those the particular thing, those the particular part that what we are having here, what we are finding this particular structure. So in this particular structure, what we can see and what we can bring it, that those the structure what is there, those the part that we are constructing it. Now as we are constructing this data, as we are making those data, what we find it that there are the different type of the loop that we are using, and using that loop we are constructing, and we are making this particular thing to be implementable. So this is what that we can find, this is what we can see. Let us see what the program we have for today. Now in this particular program, you see what we are having the nested loop program. So nested loop program, what we find here, that I have taken the value of I equals to 2. So why I is greater than equals to 0, then j equals to 2. So while j is greater than equals to 0, print 2. Then j plus plus j equals to j minus 1, print the particular thing, and I equals to I minus 1. That means what it has done, that this is a reduction loop, this is not an incremental loop. That means we have specified, or we have given the value of I equals to 2. As we have specified the value of I equals to 2, now we have done one checking here whether the value of I is greater than 0 or not. So if the value of I is greater than 0, then condition is satisfied. That means what is the value of I we have taken? The value of I that we have taken here is 2. So it is 2. So j next what it has been done, as soon as it entered, then it has done j equals to 2. Okay, j has been set as 2. Now again another checking has been done while j greater than equals 0. If the value of j is greater than or equals 0, then what it will going to do, what the work it has been given, because j value is greater than 2, so it will going to print that 2. Okay, now what we can find it, that we will going to have that j equals to j minus 1. So if you have j equals to j minus 1, that means 2 minus 1, now it will become what, 1. And print that one, that to be printed outside. Now if that value is not satisfied, then it will print it. Then I equals to I minus 1. So I equals to I minus 1 means value of I will decrease. Now the value of I is what, value of I is 1. So again it will take that value and it will going to enter the loop. I is greater than 0, yes, I is greater than 0. J equals to 2, again j equals to 2. That means first it will complete the inner loop, that j will now become what, 1. So when j will now become 1, so j greater than equals to 0, yes, then it will again go there and it will say what is the value, then it will print again 2. Again what is the value of j, j now decrease, 1 minus 1 is 0. So j is equals to 0, yes, then also it will come and it will print that 2, and then it will go outside and it will check it that what is the value of j is there. Okay, now j will be 0 minus 1, that means it will become minus 1. So you will going to see it that minus 1 is now printed. Okay, so minus 1 is there. So as this particular minus 1 is there, so it will going to compare, and as it is comparing, you say j is greater than equals to 0, no, so it will quit out from that j loop. Now it will going to see the I loop, is I is greater, so I is now decreasing. So as I is now decreasing, in the same way or the same pattern, what we find, the value of I will going to decrease. Okay, as the value of I will going to decrease, we can see it that we will going to have this particular structure. We will going to have the particular pattern. Based on this particular pattern, what we see, that we can construct this loop. Okay, so we can construct this loop and we can work on this particular loop. So as we are constructing this loop and as we are working on this loop, what we can see, what the similarity that we can find it here, the thing that we can find it here is that there are the different type of structures that we are implementing and we are using it. Okay, different type of structures that we are implementing and we are using it. So those the different pattern of structures that we are implementing, and we are using that particular structures. In this particular structures what we have, or what we can find it, that there are the different type of implementation of the data, and we are implementing the data in that way. Okay, so this is what the nested loop, that means it will going to iterate again and again by checking the value of I and checking the value of j. So as we will iterate, it will going to find it the particular pattern, and we will going to have some output from it. So let us see what is the output that we will going to have from here. So now see here what the output we get here. See, as we are running the loop, that is the first time, that is 2 2 2 j is been run, and based on the j I is run again 2 2 2 again, based on the outer loop of 1, that the thing third phase has been run. Now when we are running this, you see here last came was bracket open bracket close. Why? Because bracket open bracket close is the last area. If you remember the program, in the program what at last what we have given, that print bracket open bracket close, then we have decreased the I. Okay, so as it is going to do that particular loop thrice, then it has decreased again. This is for the case of 2, this is for the case of 1, and this is for the case of what, 0. Okay, this is for the case of 0. Then after the 0, when it is negative, it will not going to run, it will not going to have the value, so it will not going to show any output. So this is what the thing is that, so this is the part that we do have the output in this area, and we can find it that we can construct the particular output, and we can get the value, and we can run on this particular structures. Okay, so as we are running on this particular structures, as we are getting this value, we are needed to confine, we are needed to build that what is the particular data structure is, and how we can implement that particular data structure in our program, how we can make the data to be implemented, that how many time the loop is iterating, how many time the loop is running, that we need to see. So we are seeing here that the loop is been running for the first case, you see, for the first case of 2. Okay, then the second case is for 1. Okay, and the third case is for 0. So this many 3 times the loop has run, and the thing was executed in this particular way or particular manner. So let us see what is the next program we do have with us. Now see the next program. In the next program what you have, this is a demo of the nested loop. It will going to print the structure or the format. So what we have for I in a range 1 to 6. Okay, for I in a range 1 to 6, for j in a range 1 comma I plus 1, that means I will going to increase, print the value of j value will going to print, and then slash n is for what, slash n is for new line. Okay, so in this particular program what we have, so see here, it start from 1, and it will range means what we have seen it, that range will going to start from the particular structure, it will go up to that much, but before of that it will going to stop. Similarly this also run start from 1, and it will run up to that much, before of that it will going to stop, and the value of the j will going to print. So as we are constructing this particular form, as we are making this particular form, what we can find it, that we are constructing here in this particular area, what we are constructing here some certain patterns of logic that has been implemented. Now I plus 1, what will be the value of I? Now you see the value of I is what, the value of I is first case 1, then when it come inside I plus 1 means what, that it will be 1 plus 1 2. Okay, it will be 1 plus 1 2, so again 2 plus 1 3, 3 plus 1 4. So this way what we can find, that the range will going to increase till it not reach up to 5. So when it reach up to 5, then when it will take the value of I 6, that time it will say it is equals to 6. Yes, it will equals to 6. Then in that case what we will find, we will find it the thing will not going to be taken the value. That means first value of I will be taken, and taking the first value of I, that many number of time what we find, the loop will going to execute. is it? That many number of time for the second loop will going to execute. Again it will take the second value of I. Taking the second value of I, it will come inside, and it that many number of time it will going to execute. So after that what we can find, that it will take the third value of I. Taking the third value of I, it will going to have, and it will execute that particular loop. Then we can find that we will going to have the fourth value of I. As we are having the fourth value of I, based on the fourth value of I, the thing will going to execute, and it will going to show the output. Okay, so similarly the fifth value of I, as it find that is the fifth value of I, it will take out the fifth value of I, and based on that also it will going to construct, and it will going to implement. Okay, so it will going to implement. So as we find it that we do have this particular structure, we find this particular structure is there, and based on this particular structure, what we are having, or what we are implementing it here, we are implementing it a pattern that we are linking it with the previous loop. Okay, so we are linking it with a previous loop. Based on the previous loop, what we find that we get some value from there. As soon as you get some value, that value will come and initialize in the second loop, and when it initialize in the second loop will increase. So as soon as the second loop will increase, it will take and print the second loop. What is the work has been given there, that print j, it will print the value of j. Again it will come inside, it will take the second loop. Again it will going to make that particular pattern of increment, and when it is making a pattern of increment, what we see it, this particular second loop will again increase. Okay, so this is the thing, this is the part that we find, this is the thing or the structure that we can see, that we have a different pattern of structures that we are giving, or different type of conditions that we are specifying. As we are specifying that particular condition, based on that condition, what we have or what we can do, that we are constructing this particular loop to be organized and loop to be worked, isn't it? So loop to be organized and loop to be worked. So this is the loop. What we find it, that we have a certain pattern, we have a certain structures that we are making, and we are working on this particular loop. Okay, so as we are working on this particular loop, as we are forming this particular loop, so this particular loop will going to have a constructions of the data, and as it has got the constructions of the data, this will going to increase, and this will going to implement. Okay, so as it is implementing, as we find it, the thing is been implemented there. Those the implementation, or those the structures that we have, that we are constructing it here. We are constructing this particular pattern or structures, and we are implementing it in the particular form, that how we will going to make the structures to be worked with. Fine. So when we have this particular pattern, that's this particular structures, there we can see that what will the output of it. Now see the output what we have. In this particular output, see, first case it has taken out 1. In the second case it has taken out the value 1 2. In the third case it has taken out value 1 2 3. Fourth case 1 2 3 4, and fifth case 1 2 3 4 5. Now why it is so, as I have discussed it, that each of the time it will going to increase, and as each of the time it is increasing, taking that value, what it will go, it will run up to that much. So when it is starting from 1, that time what the value has been 1 plus 1 is 2. So up to that much though it has run, but it has taken out that one. So similarly for the second case, it has run for the 3 times, but it's extract the value 1 and 2. For the third case it has run for 4 times, but it has taken out 1 2 3. And in the fifth case it has taken, fourth case it has taken out for the 5 times, it has taken out 1 2 3 4 5. And last case what it is 6, it has run for 6 times, but it has extract the value from 1 to 5. Now if we are not giving a range there, then what we can find, this will going to extract the value from 1 to 6 itself. So isn't it? So this is the thing that we can find find, that means when we are giving a range means what, that it demarks that from where you have started, before of that what is their end position, before of the end position it will run up to the end position, but before of the end position it will going to extract the value. So this the extraction of the value has been done by it, and we can find it this particular thing has been worked. Okay, so let us see what is the next program is. So see the next program that we have is an Armstrong number. Armstrong number means to check the number is Armstrong or not. So that means what we see, the particular number, if you take a number, and after taking the number, if you find it that multiplication of those each of the digit is equals to that particular number, then the number will be a Armstrong number. Okay, a multiplication of the digit, and that is to be divided, and we will going to get that particular value, then we will say the number is an Armstrong number. So what we see it, first and foremost we have taken the input num, enter int input, enter the number. Okay, so initialize the sum. First we have initialized the value of the sum is 0, then we have done it here. See here, temp equals to num. Okay, that the value that has been taken from the user. So while temp greater than 0, if temp value is greater than 0, then digit, we have taken one value, digit equals to temp divided modulus 10. Modulus 10 means remainder will come and store here. Okay, then sum plus equals to means sum equals to sum plus digit into 3. Okay, that to be multiplied with 3. There what we find it, that temp slash double slash means what, we will going to get a quotient from here equals to 0. The temp equals to temp divided by 10. That means we will going to get this particular one. So if num equals to sum, then it is an Armstrong number. If else what, it is not an Armstrong number. So this is what the particular program is. This is the logic what we can find, that we have implemented the logic here, and based on that particular logic we will going to find that particular structures, and we are working on this particular structure. Okay, so this is what we can see. That means we have taken one value from the user, and as we have taken the value from the user, that particular value what we have initialized, and when we have initialized the value, we find it that we are going to do the calculations. What the calculation is what, that temp equals to num, while temp is greater than 0, the digit that we find, the digit will going to be implemented here. Okay, so as we find that this particular digit will going to implement here, in this particular digit we have structures, and we are going to build up this particular equation, that digit equals to temp divided by 10, and then sum equals to sum plus digit into 3, then temp, what is the temp double slash means as you divide it, we will going to get the value, that double slash equals to 10, then we will going to have a number, and this particular number we will going to implement it here. Okay, so this is what the particular structure is, and we are implementing that particular structure. Now let's see the particular output. Now see the particular thing, when we have run it, it has come in here. I suppose I give here 153. So as I give 153, so 153 is an Armstrong number, because if you give the square of each of this particular number, then we will going to get 153 from there. Okay, let us check another number from there. Now see here, again I have run the program, and as I run the program I give find here. So suppose I give here 122. So as I give 122 is not an Armstrong number. So from here we can get to the conclusions that when we are deriving a number, when we are constructing the number, we can find that Armstrong number is, that means when we take any three number, and when we make the cube of the all the numbers and we add them, we will find that particular number will going to come, isn't it? So this is what an Armstrong number is, and this is what we are doing it here. So in this particular program we have all these things. So today I am ending my today's session here. Thank you.